Hi friends, very good morning. Welcome to Anu Academy. In today's class in our channel, we are going to discuss refrigeration and air conditioning. Okay, we are going to discuss refrigeration and air conditioning. Okay, so let us start today's class. So if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Okay, now we'll start discussing this refrigeration and air conditioning. The term refrigeration may be defined as the process of removing heat from a substance under controlled conditions. In a refrigerator, heat is virtually being pumped from a lower temperature to a higher temperature. So this is very important statement. We have to remember this statement in order to understand the working of refrigeration and air conditioning. In a refrigerator, heat is virtually being pumped from a lower temperature to a higher temperature. Theoretically, a refrigerator is a reversed heat engine or a heat pump which pumps heat from a cold body and delivers it to a hot body. The substance which works in a heat pump to extract heat from a cold body and to deliver it to a hot body is called a refrigerant. Okay, so if you are getting a question regarding this refrigeration and air conditioning, these are the basic points, fundamental statements you have to write in your answer. Next, units of refrigeration. The practical unit of refrigeration is expressed in terms of ton of refrigeration. A ton of refrigeration is defined as the amount of refrigeration effect produced by the uniform melting of 1 ton. 1 ton, we know it is 1000 kgs of ice from and at 0 degrees centigrade in 24 hours. So we can write, since the latent heat of ice is 335 kilojoules per kg, therefore 1 ton of refrigeration is 1000 into 335 kilojoules in 24 hours. So 1000 into 335 by 24 into 60 is equal to 232.6 kilojoules per minute. So in actual practice, 1 ton of refrigeration is taken as equivalent to 210 kilojoules per minute or 3.5 kilowatts, that is 3.5 kilojoules per second. Okay, so I think you have understood this units of refrigeration. Next we will move to COP. Okay, next we will move to COP. Here I will show you coefficient of performance of a refrigerator. Okay, COP, coefficient of performance of a refrigerator. The coefficient of performance is the ratio of heat extracted in the refrigerator to the work done on the refrigerant. So theoretical, COP is equal to Q by W, where Q is amount of heat extracted in the refrigerator or the amount of refrigeration produced or the capacity of a refrigerator, that is for Q, and W is amount of work done. Okay, so the COP is the reciprocal of the efficiency of a heat engine. Okay, value of COP is always greater than unity. So what will be the relative COP is equal to actual COP by theoretical COP. Now we will understand how heat engine works, how refrigerator works, and how heat pump works. With the help of these diagrams, we will understand these terminologies. See, the first we'll talk about this heat engine. Okay, this is the heat engine, right? So heat engine, you can see this is the hot body, high temperature, and this is the cold body, low temperature in this diagram. So from heat engine, what is happening exactly here? So heat is taken from the hot body to, okay, so it is supplied from hot body to the engine. So once it is what is happening at the engine, work is done by the engine. See the direction of this arrow, it is coming from this direction. Okay, and work is done by the engine. So this is the direction of the arrow, work is done by the engine. After work is done, what is happening, remaining amount of heat is rejected as the cold body, low temperature. Okay, so you can write here heat engines, this is the heat engine, T1 is greater than TA. Okay, we can write it as T1 is greater than TA. Okay, next here you can see this is for the refrigerator, same refrigerator also. This is top part is the hot body and bottom part is the cold body. This is the refrigerator. So, but if you compare both the differences, just to see the difference of the heat engine and the refrigerator. If heat engine is there, work is done by the heat engine, whereas the refrigerator, we are giving a input to the refrigerator. Okay, so this is the difference. So if, in case of this refrigerator, we are giving a input. See the direction of the arrow. This is given moving in this direction. So input is given to the refrigerator. So what is happening? Arrow is moving in this direction from the cold body, right? Input is given to the refrigerator and it is moving to the T2 hot body. So how we can write here? Q2 is equal to Q1. So what is the input here? WR. Okay, refrigerator. WR is the input given to the refrigerator. So Q1 we are adding in, this is the input, Q1 plus WR. So this is the refrigerator. So here we are writing T1 is less than TA. Okay, so next we will see the heat pump now. Yeah, this is the heat pump. Okay, you can say this is the heat pump. So heat pump also, here also same thing. This is the hot body and this is the cold body, right? T1, T2. So input is given to the heat pump. So heat pump, what is happening here? Input is given to the heat pump, right? So see the direction, it is same like the refrigerator. So what we are writing here, Q2 is equal to Q1 plus, what is the input we are giving here? WP. So Q1 plus WP. So if you are getting a question regarding this uh, coefficient of performance of a refrigerator, so with the help of this heat engine, refrigerator and heat pump, you are going to explain, you can in your answer sheet. Okay, so that's all friends for today's class. I think all of you understood today's class. This is handwritten notes. If you are having any doubts regarding this refrigeration, okay, please post in the comments box. I will give you a reply. If you are not subscribed our channel, please subscribe our channel. Please like and share our channel. Thank you very much. Thank you for watching.